So today we're going to look at determining domain and range from a table or an equation. Yesterday we talked about what domain and range is. And just to remind ourselves, we decided that our domain was our x values and our range were our y values. So let's take a look at the table that's on our notes today. Here we can see all of our x values. Those are our domains. And it's written in a set notation. A set notation is just using those little lines here. We also have our range, which is our y. So given a table, we just look at our x and our y's to determine the domain and the range. Yesterday we also discussed function notation. We said that functions are not always written in the terms of x and y. We know that y is our dependent variable and x is our independent variable. So we can actually, instead of having our y, have our function of x. So in this case it would be our f of x. But just remember that f of x is still just representing your y. It's pretty much the same thing here. So we know that y is going to be our range and x is our domain. This will help us when we're trying to find the domain and the range from an equation. Let's take a look at example 1. Given the function f of x equals x squared minus 2 and the domain 2, 3, and 4, what is the range? So we need to know what domain and range are. Of course, we say that our domain is our x values and our range is our y values. So if we have the equation f of x equals x squared minus 2, that's just the same as having y equals x squared minus 2. So we're actually going to create a table to help us determine our range. So in our table, we're going to have our x values that we know. We know our x's are 2, 3, and 4. Our equation is y equals x squared minus 2. And what we're going to determine is our range, which is our y's. So let's go through and plug in our values for our equation. So we'll have 2 squared minus 2, 3 squared minus 2, 4 squared minus 2. And then we can solve. 2 squared is 4, minus 2 is 2. 3 squared is 9, minus 2 is 7. 4 squared is 16, minus 2 is 14. So we have just found our range. We'll write this in set notation, 2, 7, and 14. Example 2. Given the function f of x equals x plus 1 and the range -2, -1, 0, 1, and 2, what is the domain? Our range is our y, our domain is our x, and f of x equals x plus 1 can be written as y equals x plus 1. So this time we'll be plugging in our values for our y. Again, we can make a table. This time we know what our y values are. Our y values, the range, is -2, 0, -2, -1, 0, 1, and 2. Our equation is going to be y equals x plus 1, and we're going to find our domain. So let's go through and plug in these values for y. -2 equals x plus 1. -1 equals x plus 1. 0 equals x plus 1. 1 equals x plus 1. And 2 equals x plus 1. So for all of these, to get x by itself, I just need to subtract 1 from both sides. That way my 1's cancel out. -2 minus 1 is -3. -1 minus 1 is -2. 0 minus 1 is -1. 1 minus 1 is 0. And 2 minus 1 is 1. Now I have all of my domain. So I write this in set notation, -3, -2, -1, 0, and 1. Try practice 1 and practice 2 on your own. Press pause while you work. When you're ready to check your answers, press play. Check your answers for practice 1. Check your answers for practice 2 and practice 3. If you need more help, watch the video again. There are also additional videos attached to help.